Here in example 5, we're looking at a formula for the transfer of heat through a wall. We want to solve this equation for B. What we need to do to begin is to remove the fraction in this problem. So the denominator is L, so we're just going to multiply both sides by L, just like we would do with a number. So we have LQ equals KA B minus C. So we have the B there in the parentheses. So what we should do is distribute. LQ equals KAB minus KAC. I know it's a little weird when we have all of these different variables instead of numbers, but they're going to work just like our numbers do. We see that B is here in this first term. So since we are subtracting KAC from that, we will add KAC to both sides. Since these are unlike terms, we'll simply express them together. And finally, to isolate B, we want to divide by what's being multiplied, which is Ka. So our final equation is B equals LQ plus KAC over Ka. And in this context, we would know all of those values for LQ, Ka, and C, and this would allow us to simply solve for B. In example 6, we're solving for S1. Now this one's a little different because we have an S1 on both sides of the equation. We will start by distributing. So we have AS1 plus CS2 on the left and 3AS1 with the distributing and 3A squared continuing our distribution. Since we have an AS1 and a 3AS1, what I can do here is combine these because they actually are the same terms. The variable is AS1 for both of those terms. So when I have essentially one AS1 and I subtract 3AS1, that gives me negative 2 AS1. I bring down the positive CS2 and I bring down the 3A squared. I'm trying to isolate the S1, but I've at least got it into one term right now. So let's move the CS2 to the other side. We'll do that by subtracting. And I've run out of room, so I'm going to go over to the right. That brings me with 2AS1 left on the left, 3A squared minus CS2 on the right. Finally, to isolate S1, we need to divide by what's in front, which is that negative 2A, and we have S1 equals 3A squared minus CS squared over negative 2A. Now just a note, mathematically, we rarely have a negative in the denominator. So what you could actually do is you could bring the negative all the way in front, and that would make it something like this. So the negative was in front of this whole term. That might be how you would see it written. Or another way that you might write it is to actually distribute that negative into the numerator only. So you'd have a negative 3A squared plus CS squared over 2A. Now all of those are equivalent, so all of them would work. It's just noting that there's different ways to express this. Now, we would have had a completely different looking answer had we, instead of subtracting 3AS1 in that first step, if instead we had subtracted 1AS1 from the left, and then our answers would have had different signs throughout the steps, but the ultimate formula at the end would be completely equivalent.